All right, part two of extensions of Mendel. My suggestion is to be taking notes as you go along with this. You're more than welcome to freeze frame anything and read through. This is a very similar text to what your edition is, but online they update the version, so that's the version I unfortunately have to work with, but you can kind of see it's not going to change too much in terms of the content. They might give you different examples, but here we have pleiotropy. The next example, if you look at the highlighted portion here, it talks about how a single gene disease with many symptoms, because many times one gene is responsible for the outcome in many different diseases. So if you need the same enzyme in 5 different disorders or 5 different instances, and that enzyme is broken or doesn't work or you don't have the correct gene for it, then they're all going to be affected. So therefore, pleiotropy, on the outside, what you look for when you're trying to decide if something is pleiotropic, you're looking for a scenario where one specific disease, and the most common example they give is Marfan syndrome, and Marfan syndrome has many symptoms, and they don't seem to be related to someone who doesn't really understand or know the details of every single disease. But it's abundant in the eye, the heart, and so therefore you get a lot of issues. You get bones are affected, ribs. They talk about fingers and concave chest, the weakening of the aorta. So there's really this plethora of different symptoms. So they're not like variable expressivity, which we learned about in part 1, where one person can have a mild symptom while another person can have a major symptom. This talks about how in pleiotropy, one person can just have a ton of different issues. So that means that's pleiotropic. The next one is genetic heterogeneity. So you can spend time reading what is highlighted here. I'll summarize. But what you get with this is where different genes all can have the same impact. And it doesn't necessarily matter how you inherit it. Person 1 can inherit the mutation on chromosome 1, and it could lead to something like blindness. I think that's what they use in this example, and most commonly they use that. Whereas someone else could inherit a mutation on chromosome 3, and that mutation can cause blindness. So genetic heterogeneity is saying that there's multiple ways in which you can get the same outcome. They're not all related to one gene. So if you think about how that looks in inheritance, if you have blindness, and blindness is recessive, but it's recessive in different locations, then 2 people that are technically blind, you would think that they would only have recessive alleles, but if they're recessive for different genes, then the idea is that they have the dominant form of probably what the other person has a recessive form of. So you're kind of making up for that. So it's not a guarantee that their child is going to have that scenario. So genetic heterogeneity, look for scenarios where they talk about having different ways to have the same outcome. And you can read through other examples here. Osteogenesis imperfecta, that's a brittle bone disease. So that just talks, again, how they do not have the mutation that is known for accused child abuse. So what happens today? 8 genetically distinct forms of disease are recognized because there's that many different ways that you can have that particular disease.
You've been reading for some time now.
So, kind of goes back. Here's that Marfan syndrome, comparing it to, then you have many routes to blindness. So they kind of follow it up with what we just talked about. And the final thing for the kind of groupings that we're just going to finish right now is called a phenocopy. So it's a very short, very simple, read the highlighted portion, an environmentally caused trait that appears to be inherited as a phenocopy. So this is something where the environment completely makes you have what looks to be a genetic disorder. And there is a story back in the day where they talk about this. This I'm going to summarize. It's called thalidomide. And back in the day, there was this treatment for women who had morning sickness. And they gave them this drug, and this drug unfortunately caused their babies to have some deformities, but they didn't understand that there was a link between the drug that the mother was taking and the deformity of the child. They thought that the child just had this disease where there was an issue with, it was a shortening of the limbs And that does occur, genetically speaking. So there was the thought that there was just an influx of these genetic disorders happening, but it really came down to the fact that it was an environmentally caused drug. And so that's the premier example of a phenocopy. But if you see any one outside of that realm, my suggestion for these groupings is to know one example, and then you have to relate to when you see a new one that you have not been able to study before, you say, what does it most relate to? So it went through from lethal allele, incomplete penetrance, variable expressivity, pleiotropy, genetic heterogeneity, and phenocopies. So you should write down at least one example that makes sense to you, and the textbook goes through at least one for every single one of them. So feel free to understand and write down one of those, because I'll give you a worksheet that I ask you to identify what would be the scenario that most relates to this section of the textbook. All right, so we'll continue. I'm going to stop the video here to kind of go through. I think we'll switch gears with the next topic momentarily. Let me make sure that the textbook. So we talk here about Alzheimer's. I think that's a little beyond where we need to go. And then, so here, just as a chart, you kind of go through. There is a simple way. There you go. You know, can't make it any more easy than this, but make sure you understand what makes these examples fit that specific phenomenon. All right, so this chart is probably your go-to for this section. All right, I'm glad they included that. All right, see you in a bit.